Okay, so how many of you here? 8 of you, huh? Yes, Chris, John, Eugene. Okay, class. Okay, let's restart the class. Okay. So we're done with the current electricity. Today's topic going to be direct current. It's a direct current. AS you learn direct current, A2 you learn alternating current. Okay. Direct current, alternating current, two different type of current we have. Okay. Now. Okay. So what is direct current? Direct current is type of current produced from the direct, what do you call a dry cell, where the terminals are fixed. Positive, negative is fixed. It cannot interchange. The direction of the current is always one direction. Okay. Good news is the voltage is constant. Okay. You give direct current to a light bulb, the light bulb will have a constant voltage. The voltage never change. Okay. Bad thing about direct current is difficult to transmit to the from the station to the surrounding. Okay. Plus, I don't like to undermine direct current, but of course, AC alternating current is better than direct current because of two reasons. Anyone? AC is better than direct current because of two reasons. Any of you?
Wait.
Yeah.
Wait.
I can't hear you actually. So AC. The main reason why AC is better than DC because the voltage can be altered by using transformer.
Oh yes.
That's the main fundamental. I think the main reason why AC is so popular than DC. Because AC voltage can be manipulated, can be changed by using transformer. DC we cannot manipulate the voltage by using transformer. Why? Anyone? Why?
It would electromagnet.
Yeah, good. It's about electromagnet. Transformer only works based on AC. It don't works based on DC because of some electromagnetic problem. We will do that later. That's one reason. Another one reason.
Due to the voltage manipulation, you can travel further.
Voltage manipulation. Okay. Another one better answer. AC can change to DC, but DC can't change to
Okay.
AC. That's another one main reason. Your laptop uses DC, but TNB gives us AC. No problem. We have diode inside the circuit. We can change it to DC. But you have the AC component. You have like a AC motor, and TNB you have a DC supply. You can change to AC. Okay. Okay. So learning outcome. This is a long one. As usual, I don't want to go through this. You can read it. But okay. The first thing, you need to know all the symbols. Okay, in exam, they sometimes ask you to draw the circuit. You have to know the symbols. What are the main symbols you have to know? Let me show you. This all is fine. You need to know the switch. You need to know the switch symbol, cell, of course. Then ammeter, milliammeter, voltmeter, fixed resistor. Be careful. Not anymore like a zigzag one you learn in your Form 5 SPM, I think. It's just a box. It's just a box of fixed resistor. Variable resistor box also, but with a changing arrow. Heater on it. Thermistor and LDR is also placed in A2 already. Okay, this all I think on it. The diode you have to know. Light emitting diode you have to know.
Oh yeah.
Yeah.
Sir, when drawing the ones with like arrows and signs, Is there a difference towards the direction when it is at positive or negative terminal, like facing?
Positive, the arrows, is it? Or the arrows, yeah?
Like the variable resistor, the arrow is pointing like inwards or outwards or left or right?
From left to right, lah. From left to right. Like, let's say you put it at the side like this, eh?
Yes.
Let's say you put an arrow like this, okay? Or let's say a student put an arrow like this, okay? I think should not penalize. I think should be from this is I think the correct one. But if you put like this, still not penalized. The Cambridge will keep mark. They understand it's Cambridge. But better follow the actual one. Arrow with the
Yes. Does it matter of the direction when it is from positive terminal, negative terminal?
no, it doesn't matter.
Kata enak
Doesn't matter.
Alright.
Say this is positive, negative. You put like this, the arrow. Okay. The another circuit, this is negative, positive. A student put variable like this arrow. Correct. It's not wrong.
Okay.
Okay, microphone, all the others, I think not that important. Fuse, yes. Fuse, remember, 1 year they asked. Okay, these are the symbols, the important symbols you have to remember. The others, good to know. Okay. Okay. So the early slide is about EMF and PD, which I already taught you. I already taught you in the current lecture. So I skip this. Okay, I skip this all. It's all already in the current electricity. Okay. Okay. Our today's lesson is this. Okay. This is something new. Kirchhoff first law. Okay. This is, V equals to IR, the resistance, parallel resistance, effective resistance formula is what? 1 over R1 plus 1 over R2 plus 1 over R3, right? And series total effective resistance formula is what? R1 plus R2 plus R3, right? Okay, these two formulas, how they got it? From Kirchhoff's law. Kirchhoff is the founder of finding the resistance formula. Okay. So now we actually are going backwards to find out how the series and parallel resistance effective formula was found. Kirchhoff's law. And this law is very useful. When this law become very useful for something like this, let's say, for example, you have a battery, and you have a resistance here, okay, and you have another resistance here, okay. If I'm asking what is the voltage across the 1, 2, 3, and what is the current flow in 1, 2, 3, we can survive by using Ohm's law. V equals to IR will do to get the answer for this. But we unable to rely on V equals to IR alone if you have another battery here. If you have another battery here. So 2 batteries in a circuit, and you have another battery placed here, and you have another battery placed here. In other words, multiple source of battery in a single circuit, then V equals to IR is not to say not to be used. It need to be used, but we need on top of that, we need more theories to do this. Now we can't, how to find the current here, because for multiple source, we have to go to Kirchhoff law. Kirchhoff law can help us to solve this. Okay. Okay. So now our discussion is about Kirchhoff law. So what is Kirchhoff law? There are 2 laws actually. First law is conservation, based on conservation of charge. Okay. The total charge flowing into a junction equals to the total charge leaving the junction. This is the first law. Or in other words, the total current into a junction equals to total current out of the junction. This is the convention of the currents leaving the junction are the opposite sign to current entering the junction. So I1 plus I2 plus I3 is 0. So for example, Kirchhoff's first law says that, let's say you have a circuit, and you have 2 resistors here. Okay, 2 resistors here, let's say 2 resistors here. Okay, just in this circuit, how many junctions? How many junctions are there in this circuit?
2.
2 junctions. Yes. This one, there's another one. Junction. The T junction. T junction or more than that. This like a curving like this. This is not considered as junction. This is not junction. So you have 2 junctions. So according to Kirchhoffs law, at a junction, first law is about the junction. At a junction, current flow into the junction is equals to current leave the junction. That is his law. Okay, current flow like a traffic light. The junction is like a traffic light. Let's say 100 cars going into the traffic light. The same 100 cars must leave the traffic light to other side, right? So whatever current flow into the junction must leave the junction based on what? Conservation of charge. Charge is conserved. 10 coulomb going into a wire, the same 10 coulomb have to come out. That's law. So Kirchhoff first law says that the current flow into the junction equals to current flow into the junction equals to total current leave out the junction. This is Kirchhoff first law. You have a point. You see this diagram. 2 force for going in, 2 force. So according to Kirchhoff's law, total current flow into the junction must be equals to total current flow out of the junction. So current flow into the junction is what? I4, I2 and I4. So I2 plus I4 equals to current come out from the junction. I1 and I3. So I1 plus I3. This negative here, the negative here, this negative going out, you put it as negative. You can include negative if you want to write all the current to one side equals to 0. Then going out is you can put it negative. But I don't want to follow that idea. I just want to follow the first one. I2 plus I4 going in equals to I1 plus I3 coming up. Finish. All positive. Okay. Okay, so yeah, this is the first law. Okay. Tell me the answer for this. First law. What's the answer? Okay, so C, yeah. So I1 plus I2 equals to I3 over I4. So C should be the answer. Current flow into equals to current coming up. Okay, what is the equation for the A? Can you make equation for the A? All going in. Sorry, 1 going in, 2 going, 3 going in, I2 and I4 comes up. So I1 plus I3 equals to I2 plus I1 plus I3 should be equals to I2 plus I4. Okay, so I think I don't want to explain the others. Should be easy. First law. Okay, first law, easy, straightforward. Problem is this law, second law, Kirchhoff's second law. Okay, focus Kirchhoff's second law. Kirchhoff's second law is based on conservation of energy. Energy is conserved. This is second law. The sum of EMF, total energy produced in the loop per unit charge, and the sum of potential drop is total energy dissipated in the loop per unit charge. EMF is the energy stored in the charge. PD is energy released from the charge across the resistor. So Kirchhoff's second law, total EMF around a loop is equal to total EMF around a loop is equals to total potential drop in around that loop. So Kirchhoff's second law is works for a loop, for a closed loop. First law works for junction. Second law for loop, closed loop. Okay. For example, you see this diagram here. How many loops are there?
2.
2. Okay.
Oh wait, 3. Okay, I see.
So you have 3 loops. Smaller one, 2, and you have the big one also another loop. So you have 3 loops. So Kirchhoff's second law works for loops. Okay. So what Kirchhoff's second law say? In a closed loop, Okay, where is it? Okay, in the closed loop, the total EMF is equals to total potential drop in a closed loop. When you use Kirchhoffs second law, when you use Kirchhoff second law, when you use Kirchhoff second law, okay, to use that law, first you must do is identify, okay, identify the loop, identify the loop, which loop you are going to use. Okay, let's say in this case we go with the first loop, we go for first loop in the diagram. Second, you must decide which way you want to calculate the EMF, which direction, which direction you like to calculate the EMF. Is it clockwise or anti-clockwise? You decide. Okay. For the first loop, the direction I prefer you use direction of the battery. The first loop, or the direction in the first loop, you only have this battery. So this battery tend to give a current which direction? In a clockwise direction. So we choose clockwise. So in this case, we choose clockwise. Okay. It's not wrong choose anti-clockwise. Both actually correct. If let's say a student choose anti-clockwise, is he wrong? It's not wrong. It's still correct, but you got a lot of negative numbers. So I prefer to the direction of the battery so that I have a minimum negative number. I don't like lots of negative. So that's why I go clockwise, follow the direction of the battery. Okay, now the third, I use the law. Total EMF equals to total PD. Okay, what is the total EMF in this loop? The first loop. The first loop. First loop total EMF is 10 volt. It's 10 volt, only the battery. Okay. And in this loop, got how many PD? PD means potential, where the potential is dropping. In other words, that loop got how many resistance? Two resistance, right? R1 and R2. Got two PD. The V1 plus V3. Okay, right? The V1. This is, you have to be careful here. You see, the current flow in 10 ohm is I1. Which direction? I1 is to the right. You see the direction you choose. Be very careful. The direction you move is a clockwise. You go clockwise. And across the 10 ohm, you're clockwise. You're going clockwise, coming out here and coming here. At the 10 ohm, you go clockwise. Clockwise means your arrow is directed to the right. The current in the 10 ohm also directed to the right. Therefore, the potential at 10 ohm we consider as positive. Positive 10 times I1. We consider positive. Positive means what? When it becomes positive, when the direction of your direction, you either you're clockwise, anti-clockwise, you decided in the step one, step two, which direction. If you are go clockwise, you're directed on a 10 ohm is to the right, you are moving to the right. So current in the 10 ohm also to the right, same direction, that PD is positive. Okay, now you're going down, the direction is down, close to 40 ohm. 40 ohm, the current across 40 ohm, I3 is where? Also down, right? Also down. So your direction down, the I3 also going down, same direction. So I3 also positive. So it becomes plus 40 times I3. This is the equation you get. Kirchhoff second law. Total EMF equals to total PD. Okay. So you might think, why we need Kirchhoff law? With the B equals to IR also, I can make 10 equals to IR1 plus IR3. It doesn't make any difference, right? Yeah, it will make difference. As I said, it will make difference. As I said, if you go for the third loop, the bigger loop, then Kirchhoff law really very helpful. Can we go for the third loop? Find the third loop. Third loop is the outer loop, the most outer loop. Now you got 10 volt here, you got a 20 volt here. What is first step you must do? Choose a loop. Choose loop. Okay, we already choose choose loop is we choose the third one. Okay, second, choose direction. which direction you are tend to go. What do you think? Which direction do you think should go to minimize the number of negative? You go direction of the 10 volt or the direction of 20 volt? Because the direction of 20 volt, because big voltage. So we go this way. Which way is it? We go anti-clockwise direction. So I choose anti-clockwise direction. Anti-clockwise direction. Third, form the equation. Total EMF equals to total PD. Okay, tell me. Now you see, you have to be careful. What is the total EMF of this loop, the third loop? Total EMF is got two EMF, 20 and 10. 20 want the current to flow in a clockwise direction. 10 want the current to flow, 20 want the current to flow anti-clockwise direction. 10 want the current to flow clockwise direction. So total EMF is what? Because you took the direction of 20 volt, so 20 is positive. 20 is positive because we follow the direction of the 20. Okay, the 10 volt should be plus 10 or minus 10 because the direction, this 10 volt is opposing you now. Because you see the 10 volt want the current to flow upwards this way to the clockwise direction. So the total EMF of the circuit is 20 minus 10. Will be minus 10. Why minus? Because we are going for anti-clockwise direction, but the 10 volt is opposing you. 10 volt is like moving clockwise direction. So the total EMF of the circuit in this case is only 10 volt. 10 volt. Okay. Okay, now the third loop got how many PD? Third loop got how many PD? Anyone? Third loop got how many PD? So you go in the third loop, the outer loop got how many resistance? Only got R2 and R1. R3 not counted, of course, because R3 is not in the third loop. Third loop is outer one. So the PD should be the voltage of 2 plus with the voltage of 1. Voltage of 1. That is the total PD. Now tell me, the PD could be negative. When the PD could be negative, the direction you choose, the direction which you choose anti-clockwise, and the direction of the current in that resistor, if it oppose, okay, oppose means what? The current is opposing the direction you choose. Then that PD is negative. So for example, V2, go for V2 first, the R2 voltage. So I2 is flowing in the R2. I2 flowing where? To the left. I2 is flowing to the left. So the direction you choose also like going anti-clockwise to the left. So left, same direction. So PD of V2 is consider positive. How much? I2 times R2. R2. Okay, so it's positive. It's definitely positive. Then V1. Look at V1. V1, the direction you choose is anti-clockwise. You are moving to the left. But the current in R1 is I1 is opposing you. This is to the right. So the PD across R1 is negative. Negative I1 R1. This is the trick part. Negative. Why negative? And the direction you choose, the step 2, the direction you choose, and the direction of the current across that resistor opposing the direction you choose, that PD is considered negative. So then it's 10. I2, how much? I2, we don't know. So it's 20 I2 minus R1 is 10 I1. You get equation. Okay. So Kirchhoff is useful when more than one source is there. So choose a loop, choose the direction, total EMF equals to total PD. EMF to the direction, the direction of your movement is positive. EMF which is opposing you should be negative. PD also same. PD to the direction of yours you choose is positive. PD where the current is opposing you, that PD is negative. So Kirchhoff's law. Okay, you can make a lots of equation from this circuit. Can I tell you the purpose of this circuit? How many unknowns are there in this circuit? How many unknowns? You don't know the I1, you don't know the I2, you don't know the I3. Yeah, you don't know all the current. Okay, so you have how many unknown? You have 3 unknown. Tell me mathematically, if you have 3 unknown, how many equations required?
3.
You need 3. So the 3 equations, we get it from the Kirchhoff first law and second law. From Kirchhoff first law, you can get 1. Only 1. From Kirchhoff second law, you can get many. Because Kirchhoff second law got a lot of loops. A lot of loops, you can get many. But you only need 3 mathematically. Okay, by using Kirchhoff first law at a junction A, choose a junction A. By using Kirchhoff first law, I1, I2, I3, how they related? Current flow into the junction equals to current leave the junction. Which current flow into the junction? At A, you are like traffic light is at A lah. I1 is flowing into the junction. I2 also flowing into the junction. I3 coming out of the junction. Right? Like A is the traffic light, imagine. So at a junction A, I1 plus I2 equals to I3. You get the first equation. I1 plus I2 equals to I3. Okay? Okay, now Kirchhoff, use Kirchhoff's second law for the loop 1. What is the equation you get? We choose clockwise direction. So we choose clockwise direction. So total EMF equals to total PD. Focus at loop 1. So V1 equals to I1 plus R1, I3 plus R3. So 10 equals to 10 I1, 40 I3. Okay, I have to stop here for 30 seconds. Do you understand this? Any problem? First loop, Okay. And the loop 2, total EMF equals total PD. So we go to second loop. I go for follow the 20 volt direction. I go which direction? Anti-clockwise. Anti-clockwise. 20 volt equals to 20 I2 plus 40 I3. Correct? Because you are going this way, you are going this way, clockwise direction. Sorry, anti-clockwise direction. The potential drop across I from R2 should be positive because the current also same direction as yours. When you come down, the current in R3, I3 also flowing down. So same direction with you lah. So both PD is positive. So that's why it's positive. So you get another equation. I think 3 is enough already. You get 1, you got 2, you got 3. You can solve I1, I2, I3. But just for fun, Kirchhoff using the third loop, we can find more equations. EMF equals to PD. So this is where Kirchhoff law becomes so significant to be used. 2 batteries involving. So V1 minus the V2 need to be done. Okay. If you have V1 minus V2 means based on the working here, they follow clockwise and anti-clockwise. V1 taken to be positive, that means they took clockwise. Okay, clockwise. So it's going to be 10 minus 20, 10 I1 minus 20 I2. The one I did earlier, I went for anti-clockwise, 20 minus 10. But the one showing here, 10 minus 20. Is it wrong? It's not wrong. Still can, but you get a lot of negative. You get negative here, and so on. You got negative here. The EMF is negative. I don't like it. I always go for big minus small. Yeah. Any question, guys, from this slide? This is a very important part for you to understand. If you're confused here, you're going to stuck in the coming slides. So learn to make equations. Learn to make equations by using Kirchhoffs first law, Kirchhoffs second law. Kirchhoffs second law can give a lot of equations. A lot of equations. Okay. I tell you an exam. Cambridge, after you got these three equations right, mathematically you're going to do simultaneous, get the I1, I2, I3 value. But Cambridge is not interested to that. Cambridge only want you to form this equation. Want to show this equation, that's it. Full stop. They won't ask you to solve it. You don't want to go for the mathematical part. They just want to check how you form the equation by using the Kirchhoff law. Done. You get all the marks. Okay. Okay, guys. Now it's your turn. You see there is a 24 volt and R1 and 12 ohm. Of course, this circuit only one source. We can ignore Kirchhoff, but I want you to make use of the Kirchhoff. Use Kirchhoff law to determine the I total. So I total is I1 plus I2 based on Kirchhoff first law. So loop ABEFA, we use loop ABEFA, this loop, the first loop, yeah, okay. We use the Kirchhoff second law, this is second law, we use the second law, okay. So we go clockwise direction. Total EMF is 24 volt. Total EMF PD is only one potential drop. So I1 times 8. So 8 I1, so we get I1 value. We just use the loop. We just use this loop. We just use the loop. Total EMF equals to total PD, right? So I1 times R1 must be 24. Then ACDFA, the big loop, use the same Kirchhoff second law. 24 equals to 12 I2, right? The big loop, only the R2 is involved. R2 is involved. So 12 times I2, 24, I2 times 12, you get I2. Then you can find I total 3 plus 2 is your 5 ampere. I1 plus I2 is your total, so 5 ampere. Okay, this is by using Kirchhoff first law, Kirchhoff laws. Okay, any question from the slide? Okay, class, please do stop me if you have any questions. Okay, your turn. Kirchhoff first law, Kirchhoff second law. Use the law. Give me the answer for this. What is the current in the circuit? Use Kirchhoff's second law. So you can WhatsApp me your answer. So they said what? 9 ohm, cell X as 1 volt. Cell X as 1 volt. And internal resistance 1 ohm. Oh, this one you can imagine there is one resistance here also. It's like 1. You can write the internal resistance outside. Cell Y as a 2 volt, and the internal resistance 2 ohm. Oh, it also has resistance, internal resistance 2 ohm. What is the current in the circuit? So total EMF equals to total potential drop. Total EMF equals to total potential drop. The first step, you choose what? choose the direction. You want to go clockwise or anti-clockwise? I follow the 2 volt. Because got 2 volt, 1 volt, I follow the direction of the 2 volt because big voltage. So I go this way. I go this way. I go clockwise. I follow the 2 clockwise. So by using the direction of clockwise, so total EMF is how much? 2 plus 1 or minus 1? 2. The one is opposing us. 1 the current flow in the clockwise direction. 2 and 1 is each other. So it should be 2 minus 1. That is your total EMF. Okay. So total EMF is 1. How much is PD here? How many PD are there in this loop? 9 volt, 9 ohm, 2 ohm, 1 ohm. The 2 internal resistors also got PD. Potential is dropping there. What? So you have 3 PD. You have 3 PD. So I do here better. So total EMF goes to total PD. Total EMF is 1 volt. Total PD. What? The current, we assume the current is flowing to the right line, I. So that we assume the current is I. So for 2 ohm, current is flowing down. For 1 ohm, current is flowing up. For 9 ohm, current is flowing to the right, correct? It's going round line. So to your direction, clockwise direction, the current for 9 volt is same direction. The I, same direction to your direction. So the 9 volt, the 9 ohm, the voltage is positive. Positive 9 times I. The 2 ohm current is flowing down and your direction also down. So the voltage of the 2 ohm also positive. So it's 2 plus the 1 positive or negative. 1, the current is flowing up. Your direction also flowing up. So the PD also positive. So it's 1I. Therefore, total EMF is 1. This is how much? 12I. So your current should flow is 1 divided by 12. That's your ampere. What's the answer? 1 divided by 12? 0, 0. 9 something. 8. 1 divided by
0.083. Sir.
Yeah.
For the 1 ohm, right? Why can't I take the current of X?
1 ohm.
Yeah, like
1.
I minus off 1 ohm times Ix.
Oh, you see, this is only one loop. This is only one loop. Okay, let me do. This is only one loop. One loop only got one current only. Okay, this is only one loop. One loop. So you have to decide which way you want the current to place. You can put any direction you want. But later when you solve the current might give you a negative answer. Current gives you a negative answer, that means the direction should be the other way around. You know, like momentum. After collide, what is the consequence of the both body? One of the body collision might move to the left. But when we write the momentum formula m1 plus m2u, the final, both we assume moving to the right. We put plus, but finally the velocity, if you got negative answer, so we understood the direction we state up there is the other way around. Same thing here. Okay, same thing here. So in this case, the direction of the current is not stated here. But we know this is 2 volt, this is 1 volt. Where do you expect the current to flow? Current will flow clockwise or anti-clockwise? 2 volt going to push the current to the 1 volt, So the current will flow like this. So current will flow here. Current will pass through the X. X cannot release current out of it because 2 volt is big. So current will pass through the X and pass through the 9 ohm resistor. The 2 volt is like tsunami. It'll overtake the 1 volt. So what will happen? The 1 volt battery, right, will be charged. Will be charged. So don't imagine that IX got one current, I got another one current, IY. That these two current are like meeting up. No, no such thing. Okay, no such thing. There is only one current. The one current decided by their voltage already. 1 volt, 2 volt, Y wins. So the current will flow from the Y. IY only flow this way. Only one current. No such thing as IX here. You got idea?
Okay.
So only one current. One loop got one current. You decide the direction. Maybe a big voltage to the small voltage. Sometimes they give only not 2 volt, 1 volt. They put like E1, E2. We don't know which is big. If they put E1, E2, you choose the direction. Maybe you assume E2 is greater, so you can put the current coming out from the E2. Okay, you put E2. Through the calculation later, if I give you negative, then the current is actually flowing the other way around. Okay. So yeah, so 0.0083. Any other questions? Okay. Okay, before we go to this, let me send the Kirchhoff law first. Okay. Okay, this is the word file. You have to draw the symbols here. You already know the symbols. Series parallel will come back later. Just now we talk about Kirchhoff law. Kirchhoff law. Okay, these are the Kirchhoff law, the IR. Okay, first, okay, let's go through this. Okay. Okay, look at this loop. Look at this loop. You have loop 1, loop 2. You have loop 1, loop 2, loop 3. This is your loop 1. This is your loop 2. Loop 3 is the larger one. Okay, class. Okay, check. Any error? This is the final 3 formula. Is there any error in the formula made? Use Kirchhoff first law and second law. First use Kirchhoff first law. Kirchhoff first law. By using Kirchhoff first law, I1 is here, I2 is here, I3 is here. Okay, tell me, can you write an equation? What I plus what I equals to what I, or up to you? Select a junction first. Maybe the junction is G. Okay, we take the G, the traffic light G. So current flow into the junction is a current leave the junction. So can you tell me the formula? I1 flowing into the junction or leaving the junction? I1 is flowing in. I2 is leaving the G. I3 is flowing into the G. So by using Kirchhoff's first law, what current equals to what current? Current flow in, the sum of current flow in equal to the sum of current flow out. So current flow in is what? I1 plus I3 is equals to I2. Okay, so this is the first equation. Okay, now you see here, for the loop 1, Kirchhoff's second law, this is the equation. Correct or wrong? Go for loop 1. This is a loop 1. Loop 1 got how many EMF, how many battery in loop 1? Loop 1 got only one battery, E2. So you follow the battery direction. Battery direction is which way, E2? To the right. So we go which way? We go clockwise. For the L1, we go clockwise. So total EMF equals to total PD. Okay, what is the total EMF in this one loop? E2. E2. It's positive E2. Okay, now PD. In this first loop, got how many PD? In this first loop got how many battery? How many resistor? You got 3, right? You got what? You got R2. What else you got? You got R3. You got R4. You got 3 PD in this loop. Okay, now be careful. Okay. Some PD could be negative because the direction you go and the direction of the current over there, if it's opposed, that PD is negative. Okay. Now you see what current flowing at R3?
Negative I3.
Yeah, what current? I1, I2, I3. What current flowing at R3? This is another step you have to do. Okay, tell me, I2 is I2 labeled at bottom here. I2 labeled at bottom here. Can you tell where I2 started, where the I2 is finishing? Where's the beginning of I2? Which point? Where the I2 started? I tell you, remember, the range of the I current, the arrow given, it started from the back of the junction. The back of the junction. For that arrow, which is the back of the junction at the back? It's G. The junction, the immediate junction at the back. Immediate junction at the back is G. So I2 started from G. Okay. Then where I2 stop flowing? Where I2 going to stop flowing? It's going to change to other current.
C.
Yeah, it's C. So the rule is the range of a current is start from the back of the junction, the back junction at the back, immediate junction at the back, to the immediate junction in front. That's the range of the current. So I2 flow from G to C. I3 flowing from where to where? I3. What is the back junction for I3? C. The I3 flow from C to, what is the front junction of the I3? G. So I3 flow from C to G. I1 flow from where to where? I1 arrow was placed like this. What is the back junction of I1? Is it H? H is not a junction. A is not a junction. So what is the back junction? C lah. So I1 started from C and ended up at G, like the sideways this way. Okay. Okay. So now you understand. Okay, now PD. Come back to that L1 loop. We go anti-clockwise. Just now we said we go clockwise. Sorry, clockwise. What is the PD across R3 now? Current flow at I3 is I2. I2 flowing up or down? I2 flowing up, right? I2 is flowing up. So this PD positive or negative to the direction you go. Direction you go clockwise, clockwise.
Negative.
Negative. So the PD for this one is negative. I2. Plus, check the PD for R2. Tell me positive or negative. R2.
Negative.
Negative also. Negative what? Negative.
I2 R2.
R2. That's good. Yeah. Then the other one, the one R4.
Negative I3 R4.
Yes. Negative I3 R4. Yes. So this is your Kirchhoffs second law equation. That's what written here. See, I think this equation is correct. Okay. Okay, check the second one. Loop 2. Loop 2. Is this formula correct?
Yes.
Loop 2, you go, you go anti-clockwise. You go anti-clockwise, you get the same thing. The difficult one is the final one, loop 3. Loop 3, you see, I2 minus I1, E2 minus E1. That means based on this equation, they follow clockwise direction or anti-clockwise direction to form this equation. E2 minus E1, E2 minus E1. That means they took E2 as positive. That means they went clockwise direction. Okay. Okay, they go clockwise again. But you see, the outer loop is the most complex one. How many PD are there in the outer loop? How many predictions in the outer loop? Got 4. R3, R5, R1, and R2. That's why you got 4 PD. You got 4 PD here. Some PD are negative, some PD are all negative to that direction. Okay. So this is Kirchhoff law. Okay, this is your Kirchhoff law. Okay, so you can go through. There are many Kirchhoff laws here for your understanding. Yeah. Okay. Let me try to strengthen this more. Pass here. Okay, pass here. Got one question. These are all circuits. This is circuit. Go one. Yeah, this one. Okay. This is page 27. 27. Okay, just part B. Okay, part B only. Okay, your turn. Come on, give me the answer. Part B. Yeah, part B. 1 minute for you. Okay, use. So what is the first answer? Use Kirchhoff first law. Private. Oh my God, class. I think I got a problem with my, I don't know, I got a problem with my computer. Just open up the Word file, it get, what do you call, hang. Then I cannot turn anywhere. Hey class, I think it's already time's up. Give a try, the page I told you, 27. Check with the answer, do it as homework. The next class I catch up with you, the DC circuit. Okay. So please do the page 28. Page 28, do the questions. I think what? Okay, I think something's wrong. Okay, so do the questions and I get back to you tomorrow. Any questions? Because the question I told you to do, give a try as homework. Okay, so tomorrow we discuss. Okay, so no question. Stop here. Thanks.